Okay, good afternoon, students. So, yeah, today we are going to start the next part of module 3, uh, module 4, that is actually uh, MQTT protocols and COP protocols. So, these are actually protocols which are used by IoT devices, and specifically designed protocol means these devices are low constraint. We have seen this thing now, modes were there, then we have some node MCU, then protocol means the nature of IoT devices, WSN network we have seen, and even WSN network, deployment. Originally they were using these protocols such as Leech protocol or Pegasus protocol for uh, uploading the data, or what you can say, transmitting data from one point to other. Now in our what you can say deployments, which are IoE and IoT centers, so which you can see here. So this is the brief, what you can say, introduction or brief discussion about what we have said in uh, module 1. That is, when people process data and things, they come together, we have this IoE experience. Okay, and we are now working for these deployments. Second thing is that now all these nodes which are actually part of all this, no, maybe the mobile phones, then uh, these cars, then sensor connected to the smart devices, smart objects, when they are coming to things, they are communicating with each other. So as we have seen that actually these things are actually like small, uh, not small, but subset of WSN. They are essentially WSNs, but now we call them as things and network. These things are network, means they are actually Internet of Things. Okay, but now going beyond this also, when we say that now IoE, then experience is now, what you can say, more important. Experience by people. Okay, how you are going to provide them this application user experience. Okay, so you may have this, no, for example, a simple smart thing that is called as smartwatch is there, and on its own it is sensing your heartbeat, it is sensing your uh, what you can say oxygen saturation. That is one part. It is just simply no WSN part, sensing data and sending at one part, at one place. Now what is happening, suppose now your smart thing is sensing data, and then this sensing data is uploaded to the cloud server of the publisher, what you can say, your vendor, and then vendor keeps track of that thing day to day basis. Okay, that is one thing. Second thing is that when your vitals are, suppose no, it thinks that they are having some pattern that to be medically diagnosed, then this thing, your application, smartwatch application will inform you that okay, you may need to visit a doctor. Okay, and then it will keep on watching your vitals through its specific process, and it will monitor your health. So a typical watch having no simple no vital sensors is acting like no small certain kind of no uh, initiative role of doctor it is taking. And maybe then in case of some, what you can say, emergency, it may trigger the process which may inform your peers and loved ones. So this is now the, depending on GPS location, depending on no, if it may inform certain doctors, certain medical emergencies and kind of thing. A number of possibilities are there when application layer comes in picture. So starting from simple sensor to going to this thing, what you can say, full-fledged user experience, this is Internet of Everything. And to make this happen, then we have to go for a specific, what you can say, uh, protocols which are beyond the conventional ones. Okay, beyond the conventional ones, because now this, what you can say, more and more things are going to be added, they will be communicating with each other. That's why machine to machine, M2M communication, that is one aspect of your what is IoT and IoE. And beyond that, when machine to machine communication is there, all these machines might be of the same type, might be of the different type, majority times they will be having different configurations. So to make this thing happen, we have to have certain common understanding, and this common understanding comes into this protocol. So these two important protocol that we are going to discuss in this session is this part of your IoE is that first is MQTT and second is COAP. This MQTT is message queuing telemetry transport MQTT protocol, and COAP is constraint application protocol. So these two protocols are there. Mainly these protocols are used by your smart things for communicating between each other and passing on the data. So now it has taken, so rather when we have seen that simply, when WSN deployment is there, we have to now change the data and pass it on to the data, pass this data to edge device. But here, this role is much bigger. So how the things are changing here, let us find out. Okay. Okay. Let's go to next slide. Yeah. So these protocols which we are going to discuss here, they are coming under this IoT application layer protocols. Okay. So mainly used by, as I said, that no, it is smartwatch. It is having, if it is simple sensor connecting data, a simple WSN network protocol may come. But now we have to go for a bigger architecture, bigger framework, which will, what you can say, make this no IoE in place. People, process, data, and things, they four come together. So we are now talking about the application layer protocols. So again, this intention of this protocol is to exchange data. Try to understand. Intention of COAP is to exchange data. Intention of MQTT is also to exchange the data, and they follow certain model. Certain, what you can say, architectural requirements are there for each protocol. So let us see that. So constraint application protocol COAP, message queuing telemetry transport, this MQTT protocol, and extensible messaging and presence XMPP protocol. So advanced message queuing protocol, WebSocket, all join. All these protocols, they are mainly for nodes for exchanging the data. Okay, and these devices are, they are actually having, what you can say, this kind of no required. So beyond that thing, here you can mention you can see the HTTP. But HTTP is not mainly used by all IoT devices. Or some directly, I will say that at least in what you can see is its native form, it is not used. It has got certain requirement and certain shortcomings. Because of that thing, COAP and MQTT is followed. So it may happen that your node MCQ, your node MCU, that is here, it may have compatibility with HTTP. Yes, fine, because this device is supporting that thing. But for a general, what you can say, IoT network, okay, it is always better, because then IoT network, if you say that data exchange is required, we may have to go for UAP and MQTT. So why we need COAP? Why we need MQTT? Why not HTTP? That we'll see. So beyond this thing, this WebSocket, all join, MQP, these are other options. But yeah, in today's our syllabus discussion, we are not going to discuss this thing. So QAP, MQTT, these are the important protocol that is of our, what they can say, under our consideration. Okay. So this MQTT protocol, it is actually now standardized protocol. It was actually introduced by IBM, International Business Machines. They introduced this thing, and very commonly used protocol. It uses publish subscribe model. So technically, what happens that, we have seen that edge device is there or gateway device, and then there are 100 sensors or lots of sensors are there, and this they need to push the data, okay, to this edge device. So we have seen this thing. We I have discussed this thing in my previous lecture. But how it happens? How actually, if you say that you are an engineer and you want to implement this thing, how this is going to happen? What things are required? And you say that okay, you cannot, these devices, they are having hardly some flash kilobytes of RAM and some flash ROM, what you can say. So yeah, so what things are required? So that the thing which is required here are required maybe present on this central device, and then these protocols, these nodes should be having compatibility with this standard is the MQTT standard, message queuing telemetry transport standard. Okay, so why it is standard? Because actually it is OS's body is there, and they have standardized this thing in 2013 so that it can be used all over the, what you can say, deployments all over the world in a standard manner. There has to be certain what you can say things which you have to install and configure. That is the MQTT broker you have to configure. Then protocol you will have to configure. Devices has to be using that specific exchange mechanism for that. So it uses publish subscribe model. So what is publish subscribe mechanism? That we'll see, and it is controlled by the broker. So there is a broker entity and there is a client entity. Okay, clients, or you may also call it device entity, and in this client and this broker they exchange the data. Okay, so broker, as we say that no, it is a gateway device, it will host the broker, it is a software component, and it is responsible for, you can say, distributing message from the publisher to intended subscribers. So publisher to intended subscribers, it is a very important thing, because no, you may use Heroku or you may use Amazon IoT core services, then you may use an Azure IoT services. Some or the other way they use this, what you can say, mechanism. Some or the other way they use this mechanism, either this or COAP, but broker, or you will have this service which will be subscribing or to this thing, to your sensor nodes, and then you will be, your sensor node will be pushing the data, they will be publishing the data to this services. So remember this thing. So when you say that no, push the data or publish the data, subscribe to the sensor, register the sensor, you will see that some or other, what you can say, variation of this MQTT acting there. Okay, so yeah, it is a lightweight protocol first of all, and that uses publish subscribe, we have seen this thing, and exchange data between client and the server. Okay, client and server. The small size, low power usage, minimize data packets, and ease of implementation, that makes it what you can say a favorite protocol for IoT. Or essentially we have WSNs also. So now IoT, now they are WSNs under our discussions. Okay, so you can see MQTT server is there, MQTT broker is there, and it is now having various devices connected to it now, and they are now in, what you can say, action for exchanging data. So why MQTT? Why this? Why you may say that no, that slide is there. If HTTP is there and used by no, or now for example, my laptop, I am having this lecture and online, and then some kind of no exchange is happening. So my laptop is using HTTP, then it is using TCP IP for this no audio video packets which are now getting transmitted from. I think, and maybe for streaming purpose they might be using some other protocol also. Okay, so because now StreamYard is there, it is getting transferred to uh, YouTube Live, and beyond that Google Meet is there. Again, streaming is happening on Google Meet. But my laptop has got 8 GB RAM. It has got Core i7 processor, and kind of things are there. So it is very high configuration device as compared to for example, simple Node MCU, where it has got hardly some kilobytes of RAM, some flash ROM, and an entry level Tensoria processor. Okay, so it is a, that's why in case of this IoT node, lightweight things are required, because they are having constrained ROM, RAM, and processing power. Hmm? That is the thing. So then it has to be real time also. That thing actually will come later, but it for consumption of bandwidth and consumption of reduction of bandwidth and low power usage, low compute, it need to minimize the data packet. Okay, and then because of this low data packet, low data header requirement, low data packet requirement, it will minimize the network use as well as power usage. Okay, so it because of this lightweight nature, it will save both network and power, and real time, because now this, whatever the data, whatever the temperature reading or your exchange is happening, it should be in real time, it should be having lowest latency. Otherwise, if you are taking reading now, for example, I gave example of no this smartwatch reading your vitals, and it is exchanging the data with the cloud server. So if it is taking lots of time to exchange data, then it may, the intended purpose of vital monitoring may not serve properly. Okay, so that's why the real time exchange is very much required. It's real time protocol, very much required. Okay, so how it works? Okay, based on client and server, first of all. So server is the one who is responsible for handling the client is everything. But server is not as it is server here. Rather, the server is called as broker, MQTT broker. So always in MQ or MQTT deployment, you will I discuss this thing broker. So if you want to deploy this no MQTT server at your MQTT exchange mechanism on your premises, then you will have to deploy or configure one machine as MQTT server. So if you are having one gateway device or one edge device, so you will have to install this software, and then this software, this endpoint, you will have to configure with your these devices or these nodes which are there will be going to exchange the thing. So in case of your Amazon IoT core services, same thing happens that no, for that Amazon IoT core services, you will have to configure the service, and then you have to register all the nodes which are going to exchange data with that service. So it is kind of acting as a broker only, acting as a service which will take the data. It will actually register the client, and it will be subscribing the what you can see the sensor, so that sensors will keep on sending the data. So yes, that's what when the device, the client want to send data, so they will be miss if I want to send, so I will be publishing the data, and if I want to read from that sensor, then it is like I am subscribing to that sensor. Okay, so if I'm having 10 sensors, so I will and I want to read data from that, so I will have to subscribe these 10 sensors, and this subscription and publish, it will happen through a MQTT broker. So how? Here you can see this thing. So suppose here I am having here, I'm taking my lecture here. So and so I'm here VB. So I want to know what is the temperature at suppose X end. Okay, so I have deployed one temperature at the gate. Suppose it's empty gate. So this is the sensor. Here you can see temperature DHT11 sensor I'm installing through this node MCU, and here it is connected. So technically what I want to do, I will be actually subscribing the data, subscribing to this client. Okay, subscribing, and here also I will have subscribe relation, that yes, I will be getting subscription of this client through this MQTT broker. And suppose here I want to update my GPS location to what you can say for processing by no, here it is, there is some vendor server is there, and they want to process my GPS location, how the way maybe Google server. So what I will be doing, I will be having publish. So I will be publishing my GPS location to this MQTT broker. So this MQTT broker will have VB and GPS location 1, coordinate maybe 1.1, 2.2 kind of thing. So just example, if I update this timestamp wise 2.3 like this thing, 3.1, 3.2 like this thing, it will go on publishing. And then if you are subscribed to my what you can say this location update, then you will this location update will be pushed to you. Yeah, these are the location update from this client. So it is actually publish subscribe model can be seen here. This detail here you can see the component detail. So here, so publisher or sensors can be seen here. So they will be actually, these are the actually virtual channels on which this data is put, and the subscribers are there maybe on mobile application service or one data analytics service, and they want to know what is the detail of this sensor or GPS location, and they are actually subscriber, they are publisher. So here it is many to many pub sub relation can be seen. This is another important thing. Many to many is suppose if there are 10,000 sensors and there are 10 nodes which are actually processing the things, then 10,000 sensor or 1,000 sensors and 10 nodes, they will be exchanging the data. So many to many. Okay, and then in this one what you can say ecosystem, one framework, one broker is required, minimum one broker. Excuse me, if there are if you want to say that more than one zones or more than one regions, then accordingly you may have more and more of brokers. but one broker for every system is a must. At least one broker is required. Without broker, system won't work. Okay, and this subscribe public relation publish and subscribe relation may be very constrained. Means what data you send, this because these data packets are very lightweight, so it will have maybe simple integer temperature reading or timestamp reading kind of thing, and it will go on. And here you can see this pub can be even only a sensor. Yeah, as I said that no, one node MCU, it is having one temperature sensor, and it will be publishing the data. So you will have that program flashed on node MCU that on this URI you have to publish the thing on this node in this MQTT broker, you will have to publish the data. Okay, so this broker is a bigger machine, it is a server, it needs more computing power. Because if you say that there are 10,000 or 1,000 nodes, then actually the broker will be receiving data from 1,000 nodes, and then it will have to pass and serve the request of subscriber. It will have to remember, it will have, so that is the role of this MQTT broker service, that it will remember how many subscriptions are there, and accordingly whenever the subscriptions are triggered, then it will be pushing the data to that subscriptions. Okay, so like this thing. So as I gave this example, this is me and I want to read the temperature. Then the moment the temperature data is received here, it will push on to all the subscribers. So this is the publish and subscribe consent. So many to many, remember this thing, MQTT. Yeah, another thing, many to many, many to many, sub pub relationship, subscribe publish relationship. Okay, so I hope you got the concept, because now uh, here like in previous lectures we have seen Pegasus and then leech protocols. They are more of often for the data how from this sensor network comes to this gateway. Okay, but here this is like they were network layers uh, protocol, network and data link layer protocol, where this Pegasus and leech things they were coming. But now this MQTT is application layer protocol. Try to understand. It is an application layer protocol. So then whatever programs and applications which will be running on the client and you are subscribing, so they will be actually having these protocols. So this is the another example where you can see that here two clients are there, two machines. Okay, and they are having this they have subscribed to this temperature sensors, and this temperature sensor is publishing one reading to this MQTT broker, and this MQTT broker is going to see how many subscribers are there, machine 1 ID, machine 2 ID. So here it may have this IP address of this machine here 192.1.63, it may have 64, and then according to it will push the data to these two machines. Okay, so and then these events are here, you can see the device defines topic. So what subscription topics are there? So maybe this topic here is temperature, and the moment the temperature is coming, the temperature value is pushed to these two machines. So this is actually detailing of publish subscribe. So this is one, what you can say, uh, new thing that is coming, and one more protocol, that is COAP, but that is having, what you can say, different mechanism. One-to-one communication is there. So here it is many to many kind of communication model can be seen. So what are the MQTT components? So you are having a broker, so which will act as an exchange. You are having a topic on which maybe the temperature you want to publish, or humidity you want to publish, or light intensity you want to publish. So these topics are there that you will be subscribing to, and message will comprise, or they can say, the quantity or physical quantity converted into the digital one, and they will carry the readings for that specific topics and publish the process. Okay, which will pass this data from this uh, measuring node to the broker. And subscribe is what you can say, when the device want to get the data from that specific node. So this question comes this for 4 nodes. What is MQTT? What are the different components of MQTT? How it works? So this is the figure. This 4 mark to 8 mark question, and is possible on this concept. Already this we have discussed in detail in the previous slides. So how many devices? As I said, that depending on your requirement, there can be many devices. It is in typical IoT deployment, 1,000 to 10,000 sensors are there having lots of variety of what you can say topic. Only thing is that it is a digital communication. So sensors will be converting this physical energy into digital. Digital this data packets will be formed and then published depending on the topic or the sensor name. It will be exchanging data with the with your MQTT broker. Okay, so that is the beauty, because here you can see that's why the need of your IoT deployment is that it should be able to gather data from the this is engineering, gather data from lots of sensor in your sensor deployment. So we have been keep say okay, we are keep saying we have been kept saying that there will be sensor data will be exchanged, but how? This is the one technology that is going to be behind that MQTT broker. So you will have to set up a device. So if you say that no, I want to read data from FMT campus, so I will have to set up a machine which will be actually acting as MQTT broker, which will gather data from various sensors. Then it will decode the data. Then maybe depending on where you want to push it further, For example, now suppose another service you write on Heroku that will be gathering data from your security broker. So that is something. Your Amazon IoT core service will be actually acting as a subscriber for your sensor. So it will be designating specific sensor. So you will for reading purpose. So you will have to configure this thing in your mini projects. So there are various options. One more thing, uh, it is not like that always you will have to install or configure on the local machine. There are many online services also, so you can use online MQTT brokers. So your devices, you will have this endpoint for that MQTT broker which is online, and then you will be pushing data to this online MQTT server. So that is another thing that is important, that okay, nowadays because now your devices are connected to internet, it is possible, totally possible, that you can connect and configure the online security brokers also. So yes, why not HTTP, which we have I actually initial part of this lecture I told you that HTTP. So what MQTT is doing, from device X to device Y, it is carrying the message. What the HTTP is doing, hypertext transfer protocol, again from internet node X to internet node Y, X1, Y1 you can say. So it is carrying the message. Okay. But then if purpose of this MQTT and purpose of this HTTP is same, why altogether MQTT is required? Why not to use HTTP directly? And maybe in coming time you are having some devices which use HTTP directly, but when it goes on general node, and when you are having very small, very low constraint devices which are part of your IoT deployment, then again we what you can say, the basic is that these are constraint devices. Remember this thing, when IoT is there, when WSN is there, no? IoT applications, smart city applications, you have to think of constrained devices. You cannot think of laptop or mobile phone as, even if mobile phone is also a constrained device in a way that it has got battery operated phone. So you have to write an application which will optimize the battery. You can't afford to have a continuous power supply. Okay, if you do that, then it is not IoT device. Okay, somewhere or other it will have the portable nature and on the go communication. So let it be. Maybe mobile phones, they are very much capable of handling HTTP, but inherently HTTP is slower. It needs more competition. More that way, it is the best what you can say, best effort delivery. If I'm not wrong. Okay, so it has got more overhead and power consumption as compared to HTTP. So because of that thing, okay, so we don't go. The bigger data packets are there in HTTP because of header. You will see this header size of MQTT is hardly 2 to 4 bytes. Okay, so very simple headers are there. It doesn't require, because it has to save the network bandwidth and power. So in case of HTTP, there are more. So you have to send for HTTP request, then HTTP reply. These connections are there, and then the retry connections are there. So the error control is there, and number of things are there. So open and close these connections, they need more bandwidth, more overhead, and with very small data packet, data headers, MQTT server can communicate with the client. And because of this overall nature, MQTT is low in power consumption, low in compute consumption, and low in bandwidth consumption. That's why for this low constraint device, we don't use HTTP. So, so mosquito broker is one entity. Remember this thing. So it is essentially an MQTT broker. Hmm. Broker is there, and it is an open source message broker that implement MQTT protocol, lightweight. Okay, and it suits for a range of devices with Arduino, ESP32, Raspberry Pi. You can configure this MQTT mosquito broker on this device, and they can very well communicate using this publish subscribe model. Okay, then I just discussed this thing rather than configuring MQTT broker, mosquito broker on your local PC. You can go for online deployments. So here you can see this ThingMQ, Think Studio, MQTT.io, Heroku, Cloud MQ. This Heroku is having MQTT, this service, broker service is there. Then even on Amazon also, you will have these services, Amazon IoT core services, which actually act as kind of advanced brokers. They will be subscribing to your updates, and you can implement the same thing using Amazon IoT core services, Azure IoT services. These things are available. So yes, today we stop here. Next lecture we'll see COAP protocol. So just a minute.